All right. I'm struggling to move my slides. I don't know actually what is happening. It keeps on slipping. Let me try to. They are really giving me challenges. I really don't know what's happening.
Click on the site, maybe.
Come again?
I was saying, click on the site. Maybe it will start moving. I don't know.
It keeps on freezing. I really don't understand what's going on. Okay, Dinah, you'll be on standby if I struggle. I really don't understand what's happening. Okay, but I see it's moving now. My team, as I said, it's Dinah Mofokeng and Thabo Mboweni. Unfortunately, Thabo Mboweni is held up. I will continue with Dinah Mofokeng. Colleagues, as you can see, we are going to mediate our PET 1. That is the relationship between the net force and acceleration. Can you take over, Mrs. Mofokeng?
Thank you, Brasem, and let me take this opportunity to greet everyone. Let me also find out if I'm audible from your side. If you can just indicate. Thank you. Thank you so much.
Can I just interrupt? Right. Sorry for interruption. Jabu, is there anyone who's sharing the register?
No,
I asked Esther, but it looks like she's not here.
Okay, it's fine. Maybe we will contact her to send the register, but we have made a roll call. But if there is a register, I will appreciate that everybody will sign the register while it's on chat. I mean, on that.
Okay, thanks.
I just want to see on the chat that we don't have anything. No. I'll call here. You can continue, Sam. Thank you.
Thanks. Dana, the stage is yours.
Okay. Thank you so much. As I was saying, colleagues, you are welcome. Rajabu has already welcomed everyone. And I'm happy that he mentioned this part of the PET. So I'm just going to overemphasize the fact that we are having PET in term 1, PET in term 2, and PET in term 3, whereby our percentages is 40% for PET 1, and then 30% for PET 2, and then 30% for PET 3. We can move, Brasem. Right, so for this year, 2026, we are going to be having 3 experiments, whereby the first one will be determining the relationship between the net force acting on a constant mass and acceleration. And then experiment 2 will be investigating characteristics of a PN junction diode, whereas experiment 3 will be it will be electroplating a scratched copper spoon with copper. So these are the 3 PET experiments that you're going to be having in 2026. Now, I'm just going to take you through the steps on how we administer PETs. Remember, colleagues, that everything that we do, we need to have rules. We need to have some structure on how we do it. So in our case, in terms of PET, this is how we do it. The first thing is that PET must be conducted in 3 days. Maybe someone can ask and say, but ma'am, why? Why 3 days? Okay, I'm going to break it down for you. Now, when we are saying PET should be administered in 3 days, we mean the first day, that's you, the teacher, alone. You do the PET alone. Remember, colleagues, that there is no way that you can just call your learners and then you sit with them and then you start doing the PET with them, because you might get results that will shock you. It will also shock the learners. So we don't want to be all shocked at the same time. So you start alone, you build your confidence, and then on the second day, now you can do it with the learners. Remember, first day, it's you alone. Then the second day, that's where now you're going to sit with the learners and then do it together with the learners. Now I agree you have gained confidence to do it. And then the third day is the part where they're going to sit and do the write-up. And remember, the conditions must be the exam setting. They must sit down and then they write. I'm happy that Brajabu has already emphasized that part. All right. So when learners are doing the experiment or when they're doing the PET, remember they'll be doing it in groups. It's fine, they will get the same results, but every learner is supposed to get their own worksheet. When it's time for the write-up, everyone must get their own worksheet and everyone must write individually. Remember, colleagues, on day 2, when you're doing the experiment, you let them record the results, you take the results, you keep them away, safe. Then on the 3rd day, that's when now you're going to take it out, give it to your learners, and then the learners can start writing. All right, colleagues. Next one, Brasem. All right. Now that I have shared with you the steps on which you need to follow when you are administering the PET. Before you can even administer the PET, colleagues, remember that you need to go through the content. I cannot come and just say to my learners, okay, we are going to do the PET. We are going to be investigating Newton's second law. Yet I've never even taught my learners. They don't know anything about Newton's laws. So the best thing is you go back, we start with the content first. We start with the theory first. Then after the theory, that's when we can go and say, okay, now we can do the PET. So remember that this Newton's laws that you're going to be doing, or this one, that the PET that you're going to be doing, is not necessarily starting in grade 12. There is some background knowledge also that the learners need in order for them to be able to do this. I'm going to give an example of conventions. You will see as the practical is going, that learners need to know how to convert. If learners don't know how to convert, then they are not going to get it right. And that is a skill that they have learned back in grade 10. So we just need to make sure that before we conduct the PET, we go back. We take them back, and then we teach them the theory. We remind them of the things that they have already done in the previous grades. All right, colleagues? Right. So part of the things that you are going to be looking at, Brasem, you are too fast. I'm not done with that one. Right. We are going to be, the content that is related to this PET that you're going to be doing is the different kinds of forces, whereby we're talking about the weight, the normal force, the frictional force, the applied force, and all of that. Remember, colleagues, that these learners need to know how to draw the free body diagrams before they can even come and do this PET. And colleagues, I think we need to emphasize it to our learners that there is a difference between a free body diagram and a force diagram. If we can just show them the differences so that they are not confused when they come to answering of the questions of this PET. Remember that the PET also is assisting them in order for them to do what? To be able to answer questions, because some of our learners are visual learners. They need to see something. When you're talking to them and saying there is a pulling force, they need to see it first before they can really understand it, because they are not able to do what? To create a picture in their mind, or okay, this pulling force that they're talking about, how does it even look like? But when they see the PET, when they see it live, they see the experiment, then they are able to match the dots, to connect the dots and say, oh, okay, this one means that one. So that is why it's very important, colleagues, that we do the content before we can even go and do the PET, the experiment. Next slide, Brasem. Okay. Colleagues, we have I'm sure you can see this slide here, the graph paper. I think at some point we are taking it for granted that learners automatically know how to use this. And we end up not really teaching them how to use it. Most of the time, they only find it in the final exams, and then they don't even know how to use it, because normally during our classworks, we'll just let them draw. They will draw the y-axis, they will draw the x-axis. Sometimes their measurements, they just put without a ruler and all of that. But it's very important, colleagues, that we show them how to use this graph paper. And as part of their classworks, let's give them the graph paper so that they can paste it in their books, and then they will be able to use it. they will be able to interpret it. So colleagues, I'm just trying to emphasize the importance of going back and teaching our learners basics. I think what we need to do, we need to really go back to basics, because even when the learners are writing the exams, we see how much they lose marks in terms of converting, in terms of just labeling with units. Sometimes they just would label the y-axis and then they don't put units, and then they end up losing marks. So it simply means to us, as much as we are interested and we like doing the PET, but let's always also go back and emphasize those units, those basic skills that the learners need so that they can be able to pass. So what we are saying is that as much as our learners are passing also, let us not just let them pass, but we need to make sure that they pass with quality and get distinctions. So before I can even dive into everything else and the experiment, I want us to engage a little bit. I think Brasem, you will go to the next one so that we can have teachers engaging with us. Before I can even share the aim of the experiment and everything that you're going to be doing together, I want us to go through this one and engage, and I'm sure you're going to enjoy it. Brasem, can you take it over?
Austana, can I say the register, it's on the chat. Can people register on the chat, fill in the register on the chat, please? Thank you so much. I'm sorry for that.
Thank you. Thank you. Brasem?
Oh, thank you so much, Diana. Colleagues, I hope you can see the link. Ne? I just want you to go through open the link and follow these steps. It says constant object mass varying applied force. Actually, here we are going to vary the applied force while the mass stays constant. We keep the mass of the cut constant and increase the hanging mass. That is effectively increasing the force. Okay, so this actually we are doing it online first before we can do. We can actually do the experiment where we are going to manipulate our apparatus. You use the slider bar to load the cart with a 500 gram mass. Set the hanging mass to 1 gram by moving the slider. Click the start button. The cart and the hanging mass will start moving. Wait for the cart to stop, and then note down the time. The time shown on the that is the elapsed time, and then click the reset button. That will put the cart to the original position. You repeat the experiment several times. We can have 5 different values. Okay, but in this case, I will like you to do only the 3 values, and then from there we'll make the table. The table is there already. Let me show you. Let me go back to my slideshow. Here is the table on the next page. So this is the table that we are going to use, colleagues. I just want to go back and open it so that we can play together. All right, here is the link. I'm going to open it so that we can be able to play. All right, here is what we were talking about, colleagues. All right, firstly, we can use the distance of 0.75 meters. This is the distance that is going to be undertaken by what? By the trolley here. Okay, so it is 0.75 meters. Let's say 0.75, and then we can just start from 100 grams. Okay. Oh, I'm sorry. This is the mass of the cart. So let it remain at 100 grams, and then now the hanging mass we can start at 1 gram. Okay, I hope, colleagues, we are going to play together. Can I make a start? Can I make a start from my side? I hope you are also doing it. All right, let me start with my first experiment. Colleagues, am I audible? I just want to make sure that I'm not talking to myself.
Yes, you are audible.
Okay,
Yes,
thank
you
you
are
so much.
audible.
Okay, let me start. Colleagues, what
Brasam,
do you
can
see on
you,
this?
Brasam?
Hello, Mania.
Yes, can you just don't rush, just
Okay.
steady by steady so that they can follow. Are
All
they
right, thank
doing
you.
it is it Java or what? So that they can join, they can do it.
Okay, the simplest thing is just to take the link as it is. Can I go back to the link?
Maybe the link, it can be put on the chat so that people can get the link and then they follow what you are doing. They do
Yes,
as
I'll
you
copy the
are
link.
saying.
I'll copy
Okay.
the link in the chats. I'll just put it there quickly.
Okay,
Okay,
thank you so much.
Colleagues,
So
the
that
link will be on the chat. Sam doing it, can you go on the chat and copy the link and then you press so that when you say do, we do it together so that it's going to be easier and then you understand. Sorry, Sam, for
all right, thank you so
interjection.
much.
Thank you.
All right,
Here's
as
the
you can
link.
see, colleagues, we have got our cart here or our trolley. It has got the mass of how much? The mass of 100 grams, all right, as you can see. And then we have got the mass piece that is hanging here. Okay, the original mass of this mass piece is 1 gram. Okay, you can convert it to kilogram by dividing by how much? By 1,000. Okay. So what is the aim of putting the mass piece here? The aim of putting the mass, or can I give it to you, colleagues? Let me engage you. What is the aim of putting this mass piece here? Okay, let me answer it in the interest of time. It is
There's
for
a
us
hand. Mr. Tembu wants to answer. Sorry
all right,
for
thank
that.
you so much. Thank you so much. The platform is yours, Mania. Diana, can you assist?
Mr. Mtembu, I don't know where he disappeared, but his hand was up.
Maybe he's muted.
Yeah, he disappeared.
All right, let me just continue. The aim of putting the mass piece here is what? Is to do what? Is to provide the pulling force. Okay, it is to provide the pulling force. As you can see, colleagues, we still have what? We still have one system here. We still have one system. All right, so now I'm going to start. And then when I start, it means that my elapsed time is going to change from 0 to something else. All right, let me start. What is happening? Start. You see what is happening, colleagues? The card is moving, and then we've got the elapsed time of 3.932 seconds. Okay.
Brasem, sorry, Brasem, to
we cannot-
interrupt. There is Pair, who is sharing her screen or his screen that is disturbing.
Yeah,
so we
and he
can't see
kicked me
yours
out.
anymore.
It looks like he has kicked me out. I cannot share anymore. So I have to share again.
Please unshare and share again, Brasem.
All right.
Moabi?
Yeah, someone keeps on sharing. I really don't. Can you see what I'm doing now? Are you with me?
Yes, now it's visible, Brasem.
Okay, can you see what I did, or do you want me to start again? Okay, let me reset.
Can you start
Let me reset.
Yeah.
Okay, we are still using the distance of 0.75. We are using the mass of the trolley or the cart is 100 grams, and the pulling mass or the hanging mass is 1 gram. All right, let me start, colleagues. Can you see what is happening? The trolley is moving, and then now we've got the elapsed time of 3.932 seconds. Did you record it? I just want you to be engaged, colleagues. Even if you are not talking to me, please just do what I asked you to do. All right. Did you record it? The first mass, that is M1.
The thumbs are up.
Okay, here is our table, colleagues. Your M1 will be, am I right to say 0.1? It's not 0.1, because it must be 1 divided by 1,000. So what must you put on your table instead of 0.1?
0.01.
Yeah, that is 0.01. Thank you, Jabu. That is 0.01. So that is your M1. All right, now we are going to reset, and then we are going to increase the mass. How many grams can I put? 3 grams. Are you okay with 3 grams? Are you okay with 3 grams? Okay, no one is talking to me, but I hope you can hear. Let me start again and see the elapsed time. What do you see now? What do you observe? What do you observe?
There's a hand, Prasem. I think they
Oh,
want
there's
to
a-
answer. Muabi wants to respond, and Mr. Mtembu is back. I think they want to respond to your question.
Yeah, can you just give them a stage? I can't see anything from my side.
Yes, Mr. Muabi. I don't think they have unmuted, or they have. I'm not sure. Maybe they just raised their hands to show that they were listening, or Mr. Muela wants to respond to that.
Okay.
Mr. Muela.
Okay, yeah, thank you so much. I think just the conversion there, when you talk about the mass, you're talking about 1 gram, you're converting it to kilograms. So it must be 1/1,000, which will give you 0.001. That's the
Yes.
correction on that.
Okay, thank you. Thank you. Thank you for that. All right, and then your observation? When you compare experiment 1 and experiment 2, when we increase the pooling mass, what happened? What did you observe?
The time decrease.
The elapsed time decreased. So it took shorter time or lesser time. Okay. And then what did you observe when you compare the speed in the first experiment and the second experiment? Was it faster or was it slower?
It was faster.
Faster.
Okay, yeah. Someone says it was faster. Okay. So, colleagues, this is a nice experiment that you can do with your learners before they can actually do the prescribed experiment. Okay, let me increase now my pooling mass to 6 grams. Okay, so colleagues, now I hope you are busy filling in your table. We started with 1 gram, if I'm not mistaken, we went to 3, we are now on 6. And now, as we are changing the mass, or we are recording the masses, you can also record the what? The net force. What is the net force in this case? What is the net force? How do we find the net force in this experiment? How can we find the net force? We can use the formula because this is the pulling force. I'm putting the mass here so that it can be able to do what? To pull the whole system. All right. So you will actually use the what? Because it is pulling it downwards. That is the formula for, we are going to use the formula for the weight. Okay. So I think you'll be able to fill in the column for the net force. All right. let me now continue to play again. I hope if you are doing this with your learners, they'll be able to see. All right. Did you see what is happening? You see what is happening, and let me repeat it. I start again. What is happening? The elapsed time is now 1.644 seconds. Right. So the time is busy becoming smaller and smaller as I'm increasing the what? The pulling force. Let me call it the pulling force, okay? Because it is pulling the what? The whole system. All right. Colleagues, are you happy with this? If you are given the table of this nature, will you be able to fill in all the table? We have got T1, T2, and T3. And then, in other words, I did not put delta X here, but our delta X is not changing. So you'll be able to calculate the what? The delta V. All right. I think it can be easy for you colleagues using the formula delta V is equal to delta X over the changing time. All right. And then from there, maybe you can plot the graph. Ne? You can use your values to plot the graph. All right. You can also go and calculate what? Calculate the acceleration. Okay. And I think that is where most of our learners get confused. Hey, colleagues, let me just share with you now. Where do you think the learners will get confused here? Or what do you think will confuse the learners? I intentionally started with this kind of experiment before we can go through the actual experiment so that we can remove the possible misconceptions. What do you think can be the misconceptions on the side of the learners?
There's a hand, Marisi. I'm not sure if I'm pronouncing it well. Hendrikse.
Yes, it's very key. I'm just very unclear now because the table I have in the pad does not look like the table that you're using. So I'm not sure where I'm getting it wrong because I don't see acceleration on my table. It's just X mass, net force, delta T and delta V.
Yeah, this is not actually the one on the pad. We are still coming to that. All right. So this one is just for practice, so that we can remove the misconceptions before we start with the actual pad.
Okay, so I just wanted to make sure they're still going to have some they have to calculate the acceleration because they're plotting acceleration.
Yeah.
Okay.
Yeah. So I just want to check if there is any misconception that you foresee before you can start with the actual practical. Dana, is there any hand?
Yes, there's a hand.
Okay.
Mbulawa. Yeah, I think it's Mbulawa.
Good afternoon, colleague. I think the main concern here will be the conversion.
Okay.
Conversion from gram to kilogram. I think we have to emphasize that part.
Yeah. Thank you very much. Thank you very much for that. So actually, you need to teach conversions first before they can actually be engaged in this kind of activity. All right. It is noted. Any other misconception or something that can confuse the learners?
There's a hand, Siutwani.
I think another misconception could be the mass of the cart or the trolley and the hanging mass.
Yes.
It could confuse them when recording the results. Yes. I think that would be a mistake.
Yeah, thank you very much for that. This is very, very crucial. Ne? All right, learners usually get confused with the hanging mass and the mass of the trolley. Okay, hence I asked you when I started, what is the aim of putting the mass here? All right, so the aim was just to do what? To provide a pulling force. Okay, So this differs from the experiment in the sense that we are not taking the mass from top of the trolley, but we are getting the mass out of the system. All right. So the mass of the system in this case is not constant. So as you can see, this example actually differ from the actual experiment that we are going to do. All right. Can I stop it here, or is there any other input that we want to share with us, colleagues?
I don't see any other hand.
Let me stop it. No?
Okay, there is a hand, Lishoho Nolo.
Colleagues, good afternoon. Thank you, Program Direct. Leadership, Mr. Shongo here from Northwest, the DCS for Technical Sciences. I also want to congratulate the colleagues based on something that's very much important pertaining to the string. You must make sure that now the table, it is subjected to a height in such a way that now the pulling force, that is the mass there, does not hit the ground before the trolley hit the barrier. Because then by doing that, that is where now you might have like some experimental errors. In other words, we try to make sure that now that mass the pulling mass, it does not hit the ground first before the trolley hit what the barrier. Secondly, try to make sure that now, as far as everything is possible, the distance is always constant, not even an inch or whatever. Try to make sure the distance, it is always constant. If it's 1 meter, let it be 1 meter continuous towards the end of the experiment. Other than that, leadership, that is my submission from the Northwest side. Thank you.
Thank you so much. Thank you so much, Manu. Yeah, you hit it. Thank you so much. The pulling string, make sure that the mass piece does not hit the ground while the trolley is still moving. So you need to be very, very careful. I hope you are taking this home, colleagues. Ne? And then the distance must always be constant. Make sure that you do not alter your distance, all right, between the experiments. Diana, do you allow me to move to the next slide?
Yeah, if there isn't any other hand, I don't see any except for maybe Mr. Mtembu, your hand has been up throughout. So I'm not sure if you want to say something or maybe you forgot to put it down. Oh, thank you. The hand has been lowered. Mr. Mtembu, you want to say something? Okay, I don't think Mr. Mtembu has something to say. Maybe it's just a mistake there. I think we can continue. And thank you so much, colleagues, for your engagement. Thank you, Brasem, for that. Colleagues, I think with what has happened in the previous one where we looked at the slide before that, now we can actually go to the actual experiment. So this experiment that we are going to do now, remember, colleagues, we are not just doing an experiment just for fun. It means we actually have something that we need to investigate. There is something that we want to find out, or there is something that we want to prove. All right. So in our case today, we are going to determine the relationship between the net force acting on an object and the acceleration produced on a constant mass. Colleagues, from the aim, just from the aim, we need to teach our learners that we have variables already on the aim, and we need to show them how do we identify these variables. All right, colleagues. So I'm going to go straight, Brasem. Next slide. Okay, now I'm just going to take you through the apparatus that you are going to be using in this experiment. Remember, for every experiment, colleagues, we need to have a list of apparatus, the equipments that you're going to use, and learners need to know the equipments that you are going to use. They need to know how to use them. They need to know how to handle them. Right, colleagues, remember there are results. There is someone who is talking. Let me see. Okay, I've just muted. Right. Learners need to know how to handle the apparatus, because remember there are marks that they get for using the apparatus in the right way. So I'm just going to take you through the apparatus also so that you can see them. Sometimes you are not able to see or be able to know what is what. So the first one that we have there is the dynamics trolley, as you can see on the video. I hope you are able to see the video. And the inextensible string, remember colleagues, inextensible means it cannot stretch. It must not be able to stretch, all right? And then we have the 300 grams mass pieces. As you can see, they are 100 grams. And then we have the measuring scale. That can be the kitchen scale as well. All right, colleagues. And then we are also going to use a stopwatch. Remember, colleagues, if you do not have a stopwatch, you can always make use of the stopwatch in the phone, in the cell phone. All right, colleagues. And then we have the runway which has a pulley, and we are going to take that pulley. We are going to attach it on the runway. All right, that's how a pulley looks like. And then we're going to take a cloth. Remember, the cloth is used for what? To making sure that we clean up the runway. All right, colleagues, we clean up the runway. We will get to the reasons why we are cleaning the runway. All right, colleagues. And then we have the mass hanger, where we are going to hang our mass pieces. We might be having different kinds of mass hangers, but they do the same thing. And then because our runway already has a ruler on it, we don't need to have a ruler. Remember on the last one there, it says we need to have a ruler or a measuring tape. So on the one that we have, it already has the measuring tape. All right, colleagues. Now, when we going now to set up our apparatus, Brasem, next slide, you will see how it's going to look like. That's how it's going to look like. So as you can see, all the apparatus that I have spoken about, we have the runway, we have the trolley. As you can see the picture of the trolley there, you see the 3 mass pieces packed on top of the trolley. You have the string or the rope, you have the barrier. All right, colleagues, you have the pulley, which is frictionless. You must make sure, colleagues, that your pulley is able to spin. It doesn't get stuck. All right, so that it does not disturb any movement. And then you also have the mass hanger. I want you to take note of the distance also. That delta X there, it speaks about the distance. Now, the distance that you're going to measure, I want you to take note of where you're going to measure it from the trolley going to the barrier. All right, colleagues, we need to make sure that we emphasize that, because some of the trolleys, remember, they have a spring in the front. So you need to emphasize that. Check if your spring is going to bump on the barrier, then you're going to start from where the spring is. And the spring, because it goes up and down, it might even confuse your results. So just make sure that as you have the barrier, the spring does not bump. Instead, the trolley, the front part of the trolley is the one that bumps the barrier. Remember, as it bumps the barrier, that is how you are going to do what? That's what is going to help you determine the time when you are using the what now? The stopwatch. And also with the stopwatch, remember, colleagues, learners need to be at least have 3 of them, or even more, because if you're just having 1, you might not get the correct readings. So the most important part is, and we are also going to check between the 3 or the 4 learners that you're going to be having, as they are taking the time, as they are recording the time, are they having almost the same? They are not exactly going to be the same, but they can be almost the same. So that's what we need to check. And then out of them, we are going to take the average. That's the one that you are going to use. All right, colleagues. And then I'm going to take you through the procedure before we can go to the demonstration. Now that we have seen someone's mic is unmuted. Right. Now that we have seen what is it that is expected from us, the setup, how it's going to look like. The first thing that we are going to do, we are going to measure the mass of the trolley. And then we are not just measuring it only. We are going to measure it and make sure that we record it in the spaces where it's given in table 1, table 2, and table 3. We have 3 tables that are given. All right, colleagues. And then the next thing, we are going to clean up the runway. and make sure that the wheels are also cleaned up. The reason why we are cleaning it, colleagues, is to make sure that our runway is frictionless. We are actually doing what? We are reducing the friction on the runway and the wheels of the trolley. You will see when we demonstrate that it needs to be clean so that it can run smoothly. All right, colleagues. And then step number 3, that's now where we are going to set up. We are going to set up as you have seen in the previous picture. All right, you have your barrier, you have your pulley, your mass hanger, and so on and so forth. All right, colleagues. Then step number 4, remember, colleagues, we are following steps. Ne? The steps are the ones that will help us to follow the correct procedure so that we get the correct results. So we are going to measure the length of the runway from the front of the trolley to the barrier. I'm sure that is clear enough to say from the front of the trolley to the barrier. And then we are going to record it in the spaces that are provided in tables 1, 2, 3. All right, colleagues. And then we are going to make sure that we also clean the mass pieces and then place them on what? On top of the trolley. That is step number 5. I'm just taking you through the steps so that when we get to the demonstration, you already know the steps that you are going to be following. Now, step number 6, we are going to remove one mass piece from the trolley and attach it to the what? To the mass hanger. Remember, when we were at step number 1, we had to measure the mass of the what? Of the trolley. All right, colleagues? Right, I'm just reminding you. Right, that was step number 6. Step number 7, that's when now we are going to do what? We are going to release the trolley and use the stopwatch or the timing device to measure the time from the moment that the trolley is released until it hits the barrier. So we are going to listen to that sound. It means the learners that will be having the stopwatches, they also need to listen very carefully to that sound when it hits the barrier, and then they stop. And colleagues, we might take it for granted. Our learners might not know how to use a stopwatch. So we need to show them, how do we use a stopwatch? When do you start and where do you stop? All right, colleagues, let's take care of that one. And then step number 8, we are going to repeat step number 7 3 times. Maybe let me find out, colleagues, why are we doing it 3 times? Just anyone quickly. Why are we repeating the same thing 3 times? Rasem, do you see hands on your side? Or you don't see anyone? Let me see. I see a hand. Zwane.
Yes, it is for reliability.
Is for reliability. Is that the only reason, colleagues? Is that the only reason we are repeating step number 7 3 times? Anyone, colleagues? Omosanya?
To get the accurate results.
To get accurate results. Okay, colleagues, we can have more other reasons, but we have to do it more than once so that we are able to get accurate results. Thank you so much, sir. And then after repeating it, we only had one mass piece taken from the trolley to the mass hanger. All right, colleagues. And then the mass hanger, I need you to take note, colleagues. Some mass hangers, they do have weight. In actual fact, the mass hanger has weight. So as you are measuring your trolley, remember also to measure your mass hanger. Some colleagues will not be able to have the mass hanger. Remember, sometimes you don't have all the apparatus in our schools. So if you don't have the mass hanger, you will just use the string, okay, or the rope. But as long as you have the mass hanger, please make sure that you also measure the mass hanger so that you know the overall mass of the whole system. Right, colleagues? Now we move to step number 9, where now we are going to remove the second mass piece. Remember, with the first one, we only removed one mass piece from the top of the trolley to the mass hanger. Now we are taking the second mass piece from the top of the trolley to the mass hanger. All right, colleagues? And then we are going to now release the trolley. That's step number 10. We release the trolley and then we use a stopwatch to measure the time that it takes, okay? And then we record it on the table. So now we are having two mass pieces on the mass hanger. All right, colleagues? And then what are we doing? We are going to repeat it. We are going to repeat step number 10 3 times again. So it simply means every step that you're going to have, every trial run that you're going to have, you're going to repeat it 3 times so that, as Miner has said, we can get accurate results, we can get reliable results. All right, colleagues? Now that you have removed it, and then you have put the second one, you are now going to take the third one, and you're going to even notice the difference in the times, that they are not going to be the same. I like also the example that Brasem showed you to give you an idea of what is it that you are going to expect, that what is it that we want to happen in this experiment that we are doing. All right, colleagues? Right, now we are going to take the last mass piece from the trolley to the mass hanger. Okay, now as I'm saying this, I can actually think that you are having a picture. You are putting it's there in your mind. You are putting it together, or okay, I'm removing it from the trolley and I'm putting it on the mass hanger. Now you have 3 mass hangers. You have 3 mass pieces on the mass hanger. You can actually already think what is going to happen. Maybe let me just find out, what do you think, colleagues, is going to happen now that you have all 300 grams mass pieces on the hanger? What do you think is going to happen? Anyone, colleagues, can respond. I don't see any hand as yet. Now that I have 3 mass pieces on the mass hanger, colleagues, what do you think will happen to them? Maybe let's talk about the time so that you know. Okay, we have Vus Sibanyoni. Shoot, sir.
The acceleration of the system will increase.
Okay, the acceleration is going to increase. I think, colleagues, as you are doing this experiment with the learners, as you are busy explaining it, find out from your learners also, what do they expect to happen, so that at least you check, do they even have an idea of what is going to be happening, or they are just waiting? I see another hand. I'm not sure if the hand was lowered or there's an, I don't know. Mr. Lishahonolo, I see your hand.
Yeah, thank you, Program Director. Mine is not a question, not a direct answer. The answer, they've already answered you. However, I want to emphasize that, like you are saying, the colleagues need to pay attention from the beginning of the experiment in terms of from the aim. Actually, what do you need? That you need to investigate the relationship between the acceleration and net force. Hence, that's a good question to ask. What will happen in terms of the trolley, or the movement of the trolley, if now we have increased what the mass pieces on the hanger, meaning that now the net force has increased. And in terms of proportionality, we speak of acceleration being directly proportional to the net force. Hence, therefore, now we expect the velocity to increase, we expect the time to decrease. Hence, therefore, expect the acceleration to increase. But however, it's just an addition. Thank you, Program Director.
Thank you. Thank you so much. Much appreciated, sir. Thank you for that. And we are on step number. We have actually done the step number 12, where we have put the 3rd mass piece, all right? And then now we are going to release the trolley. That is step number 13, Brasem. We are going to release the trolley. And then what are we going to do? We are going to repeat it 3 times. We repeat it 3 times, and then we take the readings. Brasem, are you still with me?
Yes, it's just that I was muted. I'm sorry.
Oh, okay. Yeah, we can move to the next one, Brasem.
Yeah, before we move to the next one, I just want to pull their legs to say, when we were moving the mass piece from the trolley to the hanger, were we increasing the mass or not? What is happening to the mass?
Okay.
I think I'm talking to the possible misconception that can arise.
Yeah.
What is actually happening to the mass? Is the mass of the system remaining constant, or are we increasing the mass? There is a hand.
There's a hand, Mr. Shongwe.
Thank you, Program Director. I just wanted to, maybe I'm not sure. Should we also ask engage more or let the teachers be engaged fully, or we'll just come up if they don't say anything? Because I don't want to be seen like more of me, whereas the teachers are the one who's supposed to implement and understand everything. That is my question. Before I give the response to that question.
Can I come in there? Can Mr. Shongwe let me hang you a bit? Then allow the teachers, because I see their hands now, they are planning to answer. Let us allow them, and then me and you will come in when there are no hands anymore. Thank you.
And right leadership.
Yes, there is Khomotsegang.
Good afternoon, colleagues.
Good afternoon.
Yes, I think the mass will be constant. The only thing is that we are increasing the mass, but the mass from the start, if it is 100 grams, it won't change to anything else. It will still remain 100 grams. So the mass remains constant throughout the whole experiment. Thank you.
Okay, there's another hand, Mueller. I think the name is Gantha.
I'm sorry, can you guys hear me? I've had issues with my microphone this afternoon.
Yes, sir, you are audible. You can talk, sir. Okay, it seems like sir is having a
Measure for the
challenge.
trolley would change, wouldn't it? Because we're changing the mass.
Can he, Mr. Mueller, write in on the chat, because he's having a challenge with the mic. Can he write on the chat? Maybe we'll take the response there, so that we manage time. Is it okay, Dan?
Yes, it's perfect. I have two more hands. I have Palisa. Palisa, you can go for it, and Mogolodi after Palisa.
Good afternoon, colleagues.
Good afternoon,
Am I
ma'am.
audible?
Yes, yes.
Yes, ma'am.
Oh, to avoid misconceptions on the mass thing, I think we can emphasize to the learners that the mass does not increase, but instead we are redistributing the mass on the other side to keep it constant. We are not increasing or decreasing. We are just redistributing it on the system.
Thank you so much.
Thank you so much, ma'am.
Is there any other contribution?
Okay, I don't see any other hand. I think we can move if there isn't any.
We have PB there. I don't know who's PB. Palisa is the one
Palisa
that was talking.
is the one that just spoke.
Okay, take let her remove the hand, lower her hand.
Palisa, you want to say more? Okay, thank you. She has lowered her hand. Okay, if there isn't any other colleagues, I think we can move. Brasem.
Look at the chat. I see
Okay.
Mr. Muller has put something on the chat. So
Thank you. Okay, maybe I can just read through. It says potentially that they put in a normal force for some reason opposite the weight that acts as the pulling force. Also, how is the system staying constant if we change the mass of the hanging piece? I think for that last one, it's a question. And I think okay, there's another hand. No, there isn't another hand. Yeah, but I'm just saying, Mr. Mueller, your question has actually been answered by the previous speaker. So, but I see another hand. I have Amanda.
So sorry to just jump in there. That comment there at the top at like 3:30, that was when we were asked what misconceptions the students might have.
Oh, okay.
Sorry,
All
so
right.
it's
All right,
further
sir.
down in the chat where my new comments are. Thank you.
Okay. Thank you. Thank you, Mr. Mueller. Amanda?
Good afternoon, colleagues. Am I audible?
Yes, ma'am, you are.
I just wanted to ask also based on misconception of learners. When we started, we said that the FNet is that of the mass piece. I just want to confirm.
That's correct. The mass piece
Okay.
that is hanging.
Yes, the FNet, we was checking the relationship between FNet and acceleration. So that step number 12 is asking if we remove the mass piece from the trolley. So some learners might have a misconception into answering that because we are decreasing the mass from the trolley, acceleration will, they will answer based on the mass of the trolley as to compare to the acceleration, mass of the trolley and the acceleration instead of the mass piece and the acceleration of the tool. I'm not sure if I am making sense.
It makes a lot of sense.
Thank you.
That is why we asked this question. We are aware of that particular misconception. So we want you to be aware before you can start the experiment. Actually, that is why we stood a long time on that question, colleagues. And thank you, because we were able to see. All right. So please just be careful. Palesa said, maybe just to go back to what Palesa said. Palesa said, we are not changing the mass, but we are only redistributing it. Thank you. I think I'm covered. I think I've said a lot.
Yes. Okay, there's another hand. MM. It just says MM. MM, go for it. Your hand is up.
Good afternoon, colleagues.
Good afternoon, sir.
Yes, thank you so much for giving me the opportunity. I just wanted to clarify on the issue of the mess that the question that you was asked. I think what is happening there is the mass of the trolley. It is true that the mass of the trolley is decreasing. And it is true that the mass of the hanger is increasing. But now I think what we need to emphasize to the learners is that the total mass of the system, it remains constant.
Yes.
The total mass of the whole system remains constant. So I think when we clarify that to learners, they won't get confused. Thank you.
Thank you so much. Thank you for reminding us that and emphasizing it, colleagues. And as we are also doing that, we also need to tell them that we don't only have one variable that remains constant. So we need to teach them all the variables, and they must identify which other variables will remain constant in this experiment. Remember, we are engaging with learners. I don't know if Mr. MM wants to continue. I see Brajabu as well.
I'm just want to find out to Mr. MM when he's talking about the mass of the trolley is decreasing. I find it difficult to hear that the mass of the trolley, because remember, we've got the mass of the trolley and the mass of the mass piece together. There's not mass of a trolley. Let us correct ourselves. There's a mass of a trolley, the mass of the mass piece together. The mass of the trolley is not decreasing. If I heard it correct, but I heard the mass of the trolley is decreasing. That is not true. It's not the mass of a trolley that is decreasing. And we are just distributing the mass of the mass piece to the other side, not of the trolley. So I want us to be be aware of what we are saying at the end of the day. Because if we say to the learners the mass of the trolley, they will concentrate on the trolley, they won't concentrate on the mass piece. So it's not decreasing. Thank you so much.
Thank you so much, Prajabu. I think, colleagues, what we also need to check is the language that we use in class. It's very important. We always need to be careful of what we say to the learners, because whatever that you say, learners are they're gonna stick to it, and that's how they're also going to answer the questions in the exam. So it's very important that we use the correct science language when we are teaching our learners. I'm not sure if Mr. MM has another question so that we can move.
Yeah, I know. I think the speaker who has just spoken, he has clarified. Actually, I meant the mass of the trolley plus the pieces.
All right.
Because when you remove one piece, we are decreasing the mass of that system. That's what I wanted to clarify on that. But I think the speaker has clarified that. Thank you.
Thank you. Thank you so much, sir. Colleagues, we are still going to engage after the demonstration. Maybe let me give Sipesihle as the last one so that we can move with the experiment. Yes, Sipesihle?
Yes, hello colleagues. I had an issue with, this is Mr. Mtsemba, I had an issue with my mic earlier, so I left and then I updated my teams and now I'm back. So I think there was a diagram or an image that was shown. Now I'm confused. I was there in the earlier example where we were just adding the mass pieces. We're just increasing the mass pieces, the grams there. So in this one, just reading here from the steps, it's saying that we are taking mass pieces from the trolley and adding them to the mass hanger. I'll just, if it's not too much of an issue, just to go back so I can look at that diagram carefully so I can get a good picture of this.
Okay.
We're taking the mass, they are on the trolley, we are removing them and then adding them to the hanger to increase the pulling force.
All right. All right. Mr. Mtembu, let's go to the demonstration. I think maybe the demonstration will assist you. Just note down your question. If it's still a problem or maybe it's still not clear to you, then we can engage again. So let's just go through the demonstration of the PET experiment, and then we will definitely engage on it again. Brasem?
Yeah, can I just come in? Mr. Mtembu, actually, that was done intentionally. The example that we gave initially is different from the actual experiment. In that example, we were taking the mass outside the system. The pulling mass was coming outside the system. Now, on this experiment, the mass of the system remains constant because we are removing the mass pieces from the top of the cart or the trolley to the hanger. So they are totally two different type forms of experiments. Thank you. You can continue, ma'am.
Thank you so much.
A pleasure. As Diana, you can continue.
Okay. Can you hear me now? I was just talking to myself.
Yeah, please. Yeah.
Oh, yes. Brajawu, I was just saying, colleagues who were not able to see me earlier, they can actually see me now on the video of the demonstration. So, colleagues, Brasem, you can start the demonstration. And now we are going to start with the most important part of this experiment, where we are going to now demonstrate the steps to you. All right, colleagues. So we are just going to follow them one by one. So remember, the first step is to take the trolley and then make sure that we measure it. All right, colleagues. We measure the trolley. All right. Okay. As you can see that we have measured the trolley, we need to make sure that our runway is clear of any dust, anything that can cause friction on our runway. Together with the wheels of the trolley, we make sure that what do? We clean it with a cloth. All right, colleagues? Right. And colleagues, remember, the demonstration is just also to help the learners so that learners can actually be able to see what is going on. Now we are going to set up. As you can see, we are setting up our trolley. We have our string, we have our pulley, as you can see that. And then we are going to make sure that we put our mass pieces, our 300 grams mass pieces, 3 times 100-gram mass pieces on top of the trolley. All right, colleagues? Then we measure the distance. Remember, our runway already had measurements. So if yours does not have measurements, it simply means you're going to use a measuring tape or you're going to use a ruler. All right, colleagues? Then you take the first mass piece. What do you do with the first mass piece? You put it on the mass hanger. I'm sure colleagues can follow that. Now we are going through the steps. All right? And then make sure that the distance, you are going to measure it from the trolley to what? To the end of the buffer. All right, colleagues? Right. I want you to take note. You can either use your watch or you can also use your stopwatch. And make sure that all the time your trolley is placed on the same distance that you have started with. All right, then we release the trolley. Check what is happening. Check that spring. It is not bumping on anything. So that is not going to disturb us in our what? In our PET experiment. All right, colleagues, I want you also to look at the time that it takes from the where it started until it gets to the end there. You can see, colleagues. I want you to take note also of the other things that are happening, the experimental errors that are happening there, so that we can also engage on it. Remember, we have done it once, we have done it twice. We are going to do it now for the third time. Right? We have done it for the third time with one mass piece on the hanger now. Remember, we started with 3 on top of the trolley. Okay? Now we will take the second mass piece, we put it on the mass hanger. Okay? And every time when we do that, we make sure the distance is still the same. Okay? And remember, we are using inextensible string. All right? There we are. And then we are going to take the time. Take note. As you are watching, take note of the errors that you see. All right? And we have done it for the first time. We are going to repeat it. Remember, we repeat it 3 times. Sir has already said, so that we can get accurate results, so that we can get reliable results. Now we are doing it for the third time. We only have one mass piece now on the trolley. Right? Remember, as you are measuring with your stopwatch or your cell phone, you are recording. Learners are busy doing what? They are recording in their table of results. Make sure the distance is still the same. Okay? All right? I hope you are following, colleagues. Check what is happening there. Even the itself, I want you to also take note of what is happening. Now that we have done it 3 times, we are now going to take the last mass piece now. What are we doing? We are going to put it on the mass hanger. I think Mem has explained it to say we are distributing. Okay? We are distributing the mass. Okay? Now, I want you to take note that it is not moving the same way that it was moving when it was having all 3 mass pieces on top of the trolley, or when we were having 2. Now that we don't have any mass piece on the trolley, check how it's moving. Check the pulling force, what is actually happening. We are repeating it now for the second time. Check what is happening to that trolley. It's not moving the same way that it moved before. I'm sure you can observe that. Always make sure, or please just tell your learners to make sure that the distance is always the same. There we are, colleagues. So what we also need to check, I think one of the colleagues mentioned that we need to make sure that it does not get to the ground. Okay, mine is not getting to the ground because I'm using the lab table. Some of the colleagues might not have the lab table, as we had this challenge with some of the educators, and then we had to improvise. But remember, colleagues, that when you improvise, you need to make sure that your tables, they are level, because those are the things that we need to check. Those are the things that we need to check. What is our table level? What is it that we will disturb me getting the correct results? So I'm just gonna stop there after the demonstration. Then we can engage. Then we can move on to the next slide, Prasem. I'm gonna give over to you after the demonstration. Maybe colleagues can just show, or maybe just let us know of the errors that they have seen in this demonstration that can also confuse learners, or that can also affect the results of the experiment. I'm opening it, colleagues.
Any questions? Any inputs, colleagues? Thank you, Dana.
I don't see, okay, I see one, but I see one that was hanged to say he must wait a bit. Okay, let me open up for someone else. Lizane. Yes,
Hello,
Lizane,
ma'am.
go
Can
for
you
it.
hear me?
Yes, ma'am.
Okay, I just quickly want to ask something. I understand that you guys are saying that the mass of the trolley doesn't change. That's true, but during the experiment, you add mass to the mass of the trolley, and with each trial that we do, we remove one mass piece of that. That means that you are actually changing the mass of the object that is moving. So yes, the mass of the trolley remains the same, but the mass that has to move does not remain the same. It actually decreases, and that will also have an effect on the acceleration. That's why it's moving fast at the end. Yes, because of the net force being more, but the mass that it needs to be pulled is less. Or am I understanding this incorrectly?
Okay, remember, colleagues, we are talking about the factors that can affect this experiment that we are doing. All right, and Mem has seen that the mass is being affected by the person who's holding it, if I understood you correctly. And I'm just taking note of all the factors that you can see that they are going to affect our results at the end. I saw someone's hand, and then the hand was lowered quickly.
Allow
Mr.
this one.
Shongwe.
Yeah. All right, thank you. No, I want to add, I forgot to mention something earlier on, colleagues. You know, there's something very much important that we need to pay attention to. That is then when now, for example, the learner tried to let the trolley move and it fell down, sorry. You need to check firstly, if you have already collected the data, it means trial number 2, if you're at trial number 2 or number 3, or let's say you are at table number 2, it simply means if your trolley is destroyed, you need to repeat the experiment by having another trolley. That maybe it will measure differently. If you are likely, maybe it may measure the same, but fact of the matter, of the previous trolley and the second trolley won't be the same. So don't fix the trolley and continue the experiment, because by then there is a huge experimental error in that case. I thank you, Program Director.
All right, thank you so much. Also, maybe just to add on that, colleagues, remember when we start the experiment, we measure the trolley. So the masses of the trolleys are not the same. So we need to make sure that we take that into consideration. Thank you for that, Mr. Shongwe. Let me give to Melusi.
Good afternoon, colleagues. One of the errors that might contribute to the experiment, it could be when the learner is measuring the time when the other learner is trying to let go of a trolley. Maybe the time there could be not be that accurately, as well as when the trolley is hitting the barrier, maybe could be some less or some second that can elapse where the time cannot be that accurately. I think it's one of the areas that might be contributing toward the results. Thank you.
Okay, thank you for that, Mr. Melusi. We have Mr. Mtembu.
Hi again, colleagues. I seem to be agreeing with the miss that spoke before me, Lucia. Please forgive me, I forgot her name. But as she mentioned, it seems to me that the mass is not really the mass of the object moving. Yes, I see the explanation that the mass of the system is constant, it's just being redistributed. But why is the mass hanger considered really part of the system? Isn't it just the pulling force? So we are just there increasing. It just it doesn't make sense to me, because before now, yes, we had the mass of the hanger, but it had those mass pieces on top of it. So just like she argued, as we are taking away those mass pieces and putting them on the mass hanger, we are decreasing the mass of the object moving. So yes, it will accelerate more because of the higher net force of the weight, but also now this object, this trolley that's moving, we're also taking mass from it now. So I'm not sure. I feel like I also have a gap there. Please, if a colleague can really clarify with me, how is it? Why is the mass piece the because it's just there for increasing the net force? Why is it considered part of the system? Because I would consider the system the moving object. Thank you.
I'm just going to let anyone who wants to answer, say, can do that. There's Mr. Richard.
Thank you, Chair. I think someone had explained earlier about the mass in this system. Remember that the mass that is moved from the trolley to the hanger, it is also being accelerated. So you cannot ignore that. Then it will defeat the concept of Newton's second law, because here we are talking about the whole system. So that mass is also being accelerated. So we need to consider the mass of the system. And in this system, the mass is not changing. It's only changing the position. So that we need to explain to the learners. In fact, it will be the most difficult part that the learners are going to have, because remember, when they are asked to calculate the acceleration in a two-body system, you find learners, they struggle, especially forgetting to isolate the bodies, the objects which are involved in the system. So you need to explain at this point that the masses that are going on the hanger and the mass which is on the trolley, these are part of the system, because it accelerates the total mass. That's the mass of the trolley plus the mass of which is on the hanger. So that needs to be clarified. Otherwise, the explanation which was given earlier is fine. Thank you.
Okay, thank you so much, colleagues. I concede. Thank you.
Are you there, Dinah? Mute, unmute. Sam?
Yeah, I'm still here. Dinah,
Is Diana
the
there?
stage is yours.
But there's something on the chat that I want us to clear. There's someone, Pumzile said, preferably let the person who record the time be the same person who released the trolley. I don't think that it will be possible, but it can be. However, if maybe we have the learners who can, two or three learners who are taking time so that you can measure different times and take the average one, that will be possible. I mean, will help. But at the same time, having time and release the trolley, you may find fault because your eyes will be at this time and your hand want to react on the time, then it won't be possible. We will be having increase in time because you didn't stop immediately when it hits the buffer. So we need to be careful against that. It can be two, it can be one person who release, you talk, you count 1, 2, 3, release, and then you take the time, then you stop the time. Sometimes you can't do it dually, you will get not a preferable results. Let us be careful about it. I just want to clear that. Yes, and thank you so much.
Yeah, it looks like Dinah has been kicked out of the meeting. I'm not sure as to whether she's coming back, but she's trying to rejoin. I'm communicating with her through the cell phone. So I will just take over a little bit until she's able to reconnect so that we can save time. Let me go back to the slide show. Colleagues, this is the table that we are going to use. Someone was asking about the table. This is the table that we are going to use to record the data. So you could see that Diana was able to do all the 3 trials. That is trial 1, trial 2, trial 3, whereby in the first experiment, okay, let me just try to get to the pointer. All right. Diana, are you there? Okay. The distance was the same. All right. Here she started with the mass of, okay, to put it in grams, it was 100 grams, which is 0.1 kilograms. And then from this mass, we can be able to calculate the what? The net force. Okay. We can be able to calculate the net force. What do you use to calculate the net force? Because it is the pulling mass or the pulling force, we are just going to use W is equal to mg. All right. Are you happy with that, colleagues? And then from there, they were able, the most important thing in this experiment, the most crucial thing, colleagues, is what is the time. Okay, that stopwatch is very, very much important. That is why every time we are allowing it to be repeated 3 times, and then from there, then you are going to calculate the what the change in velocity. Let me just stop for a moment and ask you how do you or what information is going to assist you to come up with the change in velocity or to calculate the change in velocity. W, may you please take a note of the hands?
I didn't hear you, Sam. I was just reading what Diana is saying. He said he was kicked out of the meeting. Is trying to join.
Yeah. But I was saying just take,
colleagues, please mute. Mute, colleagues, please. Please check your mic. Colleagues. Let me check who's
the person from, I can't see anything from my side.
I just want to see who's talking the same so that I mute that person. You can carry on, son.
Okay, I was saying, what information will assist us to calculate the change in velocity in this case?
What do you want?
How are they going to calculate the change in velocity? Because in all the experiments, they must calculate the change in velocity.
No.
Is there
I
any hand?
see Ruabane.
Good afternoon, colleagues.
Good afternoon.
Good afternoon, colleagues.
Good afternoon.
I think for Delta V, what we're going to use is actually we're going to have to divide the Delta X that we have divided by the time that we got when we stopped the stopwatch. And can I ask something pertaining to the time? As we start the time, as the trolley is being released, and we start the time, the stopwatch, and then after it hit the barrier, we stop the watch. Are we taking that as there's this milliseconds and there's a second, or do we just consider that it's just seconds and then we use that? Or can I get clarity on the time? How should I go about the time? With the milliseconds, or I just take it as it's seconds? I don't know if I'm making sense, but I think I need clarity on that. Thank you.
Okay, thank you so much. Can someone respond to that? Can I just throw it to the house before I can come? And I cannot see the hands. No?
No, I see it on my side. Same, we've got Mr. Richard Muelo.
If there are teachers before me, let them answer, then I can come at the end. Unless there's no one.
There's no one. Okay. There is one. Let's give this one. Match mix. Yes.
Good afternoon, colleagues. The question that was asked, those are seconds. If you get like a 1.2, it's 1.2 seconds. Then I also want to talk of change in velocity. Change in velocity, we are looking at the initial velocity is 0. Therefore, the formula that is now applied to say velocity is equal to delta x over delta t. It becomes the final velocity, of which if we subtract the initial velocity, which is 0, then it gives us the change in velocity. Thank you.
Thank you so much, sir. Thank you so much. I think, Mr. Muela, you can come in now. Maybe you wanted to say something.
Okay. Thank you so much. I wanted to clarify, someone was asking about the time in terms of measuring. What I would advise you is that the timekeeper must not be one. Let's have, you can even get 3 people to take the time, because manually taking the time is so difficult. So have 3 people, then you get an average of that time that they are measuring. That is going to help you a lot, because you find that the time on impact, if it is only one person, just a glimpse of an eye may not see it, unless if you have a prop that you can connect to the bumper and you put an automatic a digital watch there that is going to record immediately on impact. That is going to be very accurate. But I know in most schools you won't have that device. So just get 3 learners to take the time and get the average, and please don't be in a hurry. You can make so many trials. There's no one who's going to give you the time that you should finish within this time. So do many trials and try to get the correct time, because that will be the biggest source of error. Thank you.
Thank you so much. Thank you so much, Paris. I concur with the colleagues, as I alluded that on the chat, somebody said the person can have move a trolley and take time. It cannot be possible. As I said, I concur with Mr. Moller to say let us have at most 3 people who are taking time, so that we get the average on those 3 people. We get we compare the time. But being alone, we won't do it. So 3 people at least will make it in terms of taking time. Thank you, sir. I don't see any hands. Mr. Shongwe, are you okay? Mr. Nambane, are you okay? Are you following? Mr. Shongwe, are you following? I just want to check with the coordinators. Mr. Shongwe, are you following? Memzama, are you all right?
Yes,
Talk
I
to
am.
me for
Hello,
this.
Mr. Yes.
Okay, thank you. Thank you. Okay. Thank you, Sam. Let's move on.
Okay, thank you so much. We now move to table 2. On table 2, the only difference that we did is that we removed the mass piece number 2 to the hanger. And then what happens is that instead of having 100 grams here or 0.1 kilogram here, we are going to have 0.2 kilograms. Oh, sorry. Under the mass, the distance will remain the same. All right. So as a result, what is going to happen? The force is going to change. Okay, that is the pulling force is going to change. So as we could see on the experiment, colleagues, the trolley was starting to run faster now. And then what happened to the time? It took lesser time. All right. And then the change in velocity will also change. In other words, it will move faster. It will show that it is having a higher velocity. Okay, let me move to the next table. That is table 3. It is almost the same as table 1.
Give Mr. Dlamini. I saw Mr. Dlamini. It's raising a hand.
Good morning, colleagues. I wanted to ask on the issue of the mass on that table. Aren't we supposed to put the mass of the whole system or put the mass that is going to be accelerated? Or we only put the mass that is going to be hanged? I just want clarity on that one.
I didn't get the question clearly.
I was asking, are we not supposed to put on the part of the mass? Are we not supposed to put the mass of the whole system or put the mass of the mass that is going to be accelerated by the net force? I'm having confusion on that one.
Remember, if we talk about the mass of the whole system, we're talking about the mass of the mass piece, the mass of the trolley, the mass of the pulley. That is the mass of the system. So I don't understand if you're saying we're taking the mass of the system where, because we are only taking the mass of one piece to the hanger, so that we get the pulling force, so that we determine the acceleration of the the relationship between the acceleration and the net force. So we are taking from the system stays, the mass of the system stays as is. We are just taking one mass of the trolley. Remember, if we take the mass piece of the trolley and the mass, the mass of the trolley and the mass pieces, they are all together there. And then you have the other one from that is hanging down there. You take one, you put it on the pulling hanger there. So we are not disturbing any.
You are no longer audible, Jabu.
Sorry.
Jabu, I don't know whether you are disconnected or not. Okay, but I can hear you now.
Okay, yeah, I'm in. I was just saying it that you are not disturbing any mass of the system, and we are not decreasing or increasing anything. We are just distributing other one to the other one, so that there is an acceleration between the force and the the acceleration of the trolleys, because it's what we want. If there is an increase of the pulling force, there will be an increase to the acceleration as well. Maybe that's how I would explain. Sam, I see there are many hands that are coming. Let me start by Mishmesh. You are the one I saw first. Can I take you if you're still there? Then I see Faith. Faith after Mishmesh. Can you come? And then it's Faith thereafter. Then we'll take as we go.
Yeah, considering the question of the previous speaker, I would like to think the mass that is in the table, written mass brackets kg, it is only there to help learners to calculate our Fnet, which is our net force. So that has got nothing to do with the total mass of the system. It is only there to conscientize learners that the mass that we have taken from the top of the trolley, the one that is going to cause the weight, which is the pulling force. So the mass that is there has got nothing to do with that mass of the whole system, the mass that is in the table. Thank you.
Thank you so much, Faith. Opana Faith.
Good.
Thank
Yes,
you.
good afternoon, colleagues. So on the very same note with regard to mass, I think I do understand the previous speaker with regard to mass, where it's written mass of the trolley. Because when we start with the experiment, we measured the trolley only, and then we took that mass. Then now the question is based on the mass from the table to say, are we recording the mass of the mass piece only, like we are saying 100 grams that needs to be distributed to the hanger? So is it the mass that we need to fill on the column, or do we write the mass of the trolley alone, or mass of the trolley with the 300 grams mass piece together? I think that was the question, to say on top there, do we write the mass only of the trolley or with the 300 grams? Then on the block, do we only focus on the mass pieces which was redistributed to the hanger? I think you said.
Thank you so much. Thank you, Faith, for your question. It's noted. H. Omosanya.
Yeah. Good afternoon, colleagues. I think the meme that answer the question now. No, he didn't answer. I think the question, he asked the question. That is what I wanted also to ask about the masses. The mass to be recorded in the columns and the mass of the trolley. That is the question I wanted to answer. Thank you.
Okay, I think there is a question on the floor. Anyone to assist, colleagues? And we all know that the mass of the trolley will remain constant throughout in all the experiments. Jabu, are you still there? It looks like I've lost Jabu as well. Can you hear me, colleagues? Am I audible,
Yes,
or
we
am I
can hear
alone?
you.
Yes, you are audible.
Okay,
Yes,
thank you so much. Can I proceed? I cannot see the hands. It looks like I've lost Jabu. Can I proceed to the next slide? Okay, colleagues, let's now
Sorry, sir.
look at.
So Esther speaking.
Sorry,
Sir,
come again.
it's Esther speaking. I don't think that the question of the colleagues has been answered yet.
Okay, thank you, Esther. Are you here?
I'm here.
Colleagues, thank you so much. Are you responding to the question?
Leader, let me respond to the question, leadership. Mr. Shongwe.
Okay, thank you.
Thank you, leader. I'm not sure maybe I got them correct because I had a challenge of a network. But pertaining to recording you will be writing the mass of the trolley there for table 1, 2, 3 remain the same. If it's 0.4, it's going to be 0.4 table 1, 2, 3 at the top. Now, here's a catch now. Pertaining to moving the mass piece to the hanger, that mass piece hanger that you move, if it's 0.1, it is the one that will be recorded there inside the table now. Table, I mean, first trial, second trial, third trial will be the same thing. Hence, it will assist you actually to get the net force. From getting the net force moving forward, it will assist you to get the time and also what the velocity there. So you don't record both. You only record the 0.1 that you put there from the hanger so that you can calculate what your net force. Remember your net force there, it will then be what? It will then be what the weight or the gravitational force, because we said we are having a frictionless surface. In other words, the net so the weight will be equal to, but in opposite direction to the what, to the tail sheet. Hence, therefore, your net force will be what? Mg. Okay. Then you will be using the mass of the hanger only. You record it there in that table. You don't add anything. You don't add the mass of the trolley. Neither add the mass of the piece there. Just take the mass piece 1. You write 0.1, 0.1. The second table 0.2, 0.2, 0.2. Third table 0.3, 0.3, 0.3. You know why? Because if you want to add them now, it means now you will need to manipulate the experiment, add another column whereby, for example, if you want to get the acceleration, you'll use what? Mass of the system plus mass of the hanger all together having the net force. That is another experiment for another time. But for now, you need to record the masses there that you are moving from the trolley to the hanger. You record in table 1, table 2, table 3. For the mass of the trolley, you record it there at the top of there. Thank you.
Thank you so much, Louis. Can I proceed, Esther? Colleagues, now we are on allocation of max. This is crucial, colleagues. This part is very, very crucial because here we are talking about the skills. The first one is the correct setting of apparatus. It's 2 marks. And colleagues, let us make sure that at least our learners get the marks on this one. And then we've got the cleaning of the runway, the wheels of the trolley, and the frictionless pulley, 1 mark. And for 3 marks, colleagues, that is the accurate measurement of the length of the runway, the mass of the trolley, and the time. And then following the sequence of the instructions accurately and logically, it's 1 mark. So for the skills, we've got how many marks? 7 marks, if I'm not mistaken. So colleagues, let us make sure that at least these 7 marks, our kids are able to score marks there. Right. Still on mark allocation, data presentation, 1 mass piece on the hanger will be 5 marks. 2 mass pieces on the hanger will be 5 marks. That is 1 on the trolley, and then 3 mass pieces on the mass hanger, none on the trolley, 5 marks. I think you can see where these marks are coming from. Let me go back to the table. All right, so for this average, it means that the learner will get 1 mark. For the average here, for the mass, 1 mark. For the average here, 1 mark. For this one, 1 mark. So they add up to 5 marks. I hope you are happy with that. So as we can see, for 1 table, the learner is going to get how many marks? 5 marks for table 1, 5 marks for table 2, and 5 marks for the third table. Colleagues, I want you to watch the following videos. Esther, you will take care of people who are raising up hands because I cannot see. I'm on the presentation mode. I want you to check.
Rasem, I'm back.
Oh, thank you.
Yes,
thank you so much. All right, I'm almost on the last slide. All right, I want you to watch the following videos. I'm going to show you the videos. These are the videos of the actual practical that was taking place. That was done by the subject advisors in the Gauteng. So I'm not saying that there were no misconceptions, but you can pick up the misconceptions. We can look at the videos and advise us on how we can improve this practical. And then you can just check if there is anything that is impractical or that is not possible. I want you to evaluate the whole experiment as to whether it is possible in a normal school situation. Can you please mute the person? In a normal school situation, colleagues. Can I proceed to the videos? Not going to show you all the videos, but I was able to take some. I'm going to take only video 3 and video 4, and I will allow you to watch them. These are the subject advisors. They were doing this before they could take it to the teachers. So I want you to take some few minutes of your time to watch. That's it, colleagues. Have you learned something from this? Have you learned something from this experiment? Am I audible? They were actually doing it.
We have
Before
a
you can
hand,
go to the
Prasem.
teachers.
There's a hand. We have Lilita,
Thank you.
Jali,
Recognize it.
Lilita, Jali. Go for it, ma'am. Please unmute. Lilita, please unmute yourself. It seems like ma'am is having a problem. Ma'am Lilita, if you are unable to say something, please just write on the chats. Maybe we can get it on the chats. There's a question on the chats from Vanessa. I'm not sure if it has been answered as yet. It says, it is confusing because we are looking at the mass being distributed. So in the table where it says mass of the trolley, should it not say mass of the system? And then only will the mass remain constant, because if we are only looking at the mass of the trolley, it does not make sense about the distribution of the mass in the system. It's a question. I'm not sure if it has already been answered because I was kicked in and out of the meeting. Prasem, was it answered? I don't think it's answering this video.
Yeah, I think it is based on the previous slide.
On the previous slide, okay.
Yeah, someone from Northwest has actually responded.
Okay,
I think
I think Mr. Mtembu wants to respond to this one. Mr. Mtembu, you can just unmute.
Hi, colleagues. No, I'm not trying to answer this one. I must answer. I just have a question regarding the video. I saw that when they moved the mask to the hanger, it was wobbling a little bit. Now I'm just curious if does that maybe affect the result in any way during maybe the quick doing the experiment? Should we wait for it to stop wobbling or no? It won't affect the results. It's fine to just shoot away while the mass piece is still wobbling like that. Thank you.
I'm not sure if everyone got or is my side say was not.
I could not hear anything.
Sorry, audible now. I was hello.
Yes, sir.
I was asking because I saw in the video that when they moved the mess from the trolley to the hanger, the hanger was sort of swaying side to side. Now, I was wondering if does that affect the results in any way, or it's fine, or should I tell the learners to maybe wait for the hanger and the mess, the hanged mess piece to stop swaying, or it doesn't matter? Just that was my question. Thank you.
Thank you for that observation. Remember that, it was done by the subject advisors, but there are still some experimental errors that you can observe. And thank you. That is an eye-opener for most of us. Thank you for that. Ne? And I think it was an oversight on the side of the group that was doing that particular experiment. Yes, if it
Thank
is
you.
going
We
from
have.
side to side.
Sorry. Thank you,
Am I
Brasem.
audible? Okay, thank you.
Yes, Brasem. I was just indicating that we have another hand. We have match mix. Match mix.
Yes, I wanted to raise something. My laptop's battery is going to die any moment, but I wanted to raise on that table where we are calculating averages. There is the issue of not having the same average if people rounded off on the change in velocity right from the top. That is the first thing. So I wish we could have consistency in terms of rounding off probably to 2 decimal place. Then the average that we also calculate will also be something that is uniform. Then the other thing that is there is when it comes to the average on the last column, it is the average of the change in velocity.
Okay, yeah, I think you're audible enough. Here is the question, colleagues. Is there anyone who's responding to this?
No, Chair, I think it was not a question. It was like just like a comment. I think we can move. He was just aiding, actually. It was not even like asking a question, the previous speaker.
All right. Colleagues, do you allow me to project video number 4? Okay, that's it, colleagues. Have you learned something from this one? Did you see that there were about 5 people who were taking the readings or who were measuring time so that they can avoid experimental errors? I think I was just jumping in so that we can save time. Ma'am, are there any hands there, or do you allow me to proceed? Mrs. Mofuten, are you still with me?
Oh,
Or
yes.
maybe I'm okay. Do you allow
I
me to
don't
continue?
see hands as yet. I don't see any hands, Mr. Sam.
All right, thank you. Colleagues, as you can see on my screen, these are because I said the subject advisors were doing the experiments in the Gauteng province. So these are the charts, because when we do the experiment, they must be involved as well. Okay, so we did it with them, and they were all involved, and these are the charts that we got from them. I hope you can see these are the tables, right? They were actually very much involved, as you can see. So as you can see, for table 1 or experiment 1, they did it 3 times with the same distance, with the mass of 0.1 kilogram. And then let me start with time. As you can see, there was a little bit of consistency when it comes to time, right? And they were able to take this mass and convert it to what? To the net force. As you can see, it's 0.98. And then as a result, they were able to use the formula delta x over delta t to calculate the velocity. And then they came up with what? With the average, the average of the velocities that they got. All right, and then they proceeded to experiment number 2. They did it 3 times as well, whereby they were using the mass of 200 grams. They converted to kilograms, and then they were able to calculate the pulling force. All right, and then look at the time. You can see that there was a little bit of consistency. It was between, or most of them were around 0.75, if I can put it that way. And then the average is 0.75. And as I said, colleagues, and I still want to emphasize, time is very, very much important. Right, then they were able to calculate the velocity. Then they moved to the next experiment, whereby, as you can see, the distance is the same, and the mass has increased, or the pulling mass has increased now to 0.3 kilograms. As you can see, they were able to calculate the pulling force, and then look at the time. Look at their time. They were very, very close to one another. All right, so they were so accurate. And then the average gave us 0.57. And then we were able to get what? We were able to get the velocity there. So as you can see, this is how our learners are going to collect the marks. Colleagues, I hope you are happy with this. I will proceed to my next chart, whereby I'm going to show you the type of the graph that they were able to get. I'm interested in this graph. Although they were not so much accurate, but you can see some skills, colleagues, here. You can see on the horizontal axis there, there is some kind of consistency, 0.5, 1.0, 1.5, 2, 2.53. So you can see that there is consistency. And moving to the vertical axis, they do not just put the values, 0.5, 1.0, 1. So these are the skills that we need to instill when we teach our learners the graphical skills. And then you can see that some of the points were out of the line, but we have got the line of the best fit here. That is starting from the origin. Okay, colleagues, I think there is something that we can take home here. All right, one thing that I just want to check with you, we are now left with what? With the acceleration. How do we find the acceleration? How do we find the acceleration? Is there any
There
hand?
isn't any hand as yet, Prasem.
Okay.
So are we allowed to talk?
We have
again?
Mariki and
Yes,
Faith.
yes, you are allowed. I'm sorry, Diana, to patch in. I'm sorry.
Okay.
Should I talk or not?
Maybe let's give Mariki a chance and then we'll come to Faith. It seems like Mr. Shongwe, it's not there anymore.
I just wanted to answer
No,
the question.
as long as
with
they have raised the teacher.
I just wanted to answer the question with regards to acceleration. We'll just do change in velocity over change in time. So it would be VF minus the VI, which was 0 to start off with, and over the time that we measured.
Thank you so much. Thank you so much. Diana, are you satisfied?
Yes, Prasem. There's Palis. No. Okay, she has lowered her hand. We have Mtali.
Okay.
Mtali TK. Go for it. You can unmute. I'm not sure if it's Mr. or Mrs. Mtali TK. Please unmute.
Afternoon, colleagues.
Good afternoon.
Good afternoon.
Afternoon, ma'am.
Yes, I'm saying it is correct to say that the acceleration will be calculated by change in velocity divided by change in time. A equals to change in V over change in T.
Okay. Thank you so much. Thank you so much.
Okay.
Is it correct that the graph must start from the origin? Diana, there's no response. Can we maybe proceed?
I don't see any hand. Yes, Prasem.
I just keep on pulling their legs. Ne?
Can you give it to Mr. Shonono, maybe?
Yes.
Because you
Okay,
wanted to
okay.
say Mr. Shongwe.
No, thank you, leadership. They've covered everything. But now I want to speak of pertaining to the graph. Ne? Based on, I don't know, I don't have the marking guideline, I have not yet received it. But now, in terms of what the question seek, it says learners must use the values calculated there and there to plot the graph. So, starting at the graph at 0 to 0, yes, it might be there, but I don't think it will be a twins mesh pertaining to the question where they will be responding to say, use the provided values to plot what? The graph. They were specific to refer to the average acceleration, also the net force there. So, yeah. I think now again, it might happen that now obviously it does happen like experimental errors. We might not have the straight lines. Hence, the teachers need to start the method of using what the best fit line. So yeah, so starting at 0 to 0, like if you don't have exactly obtained the real accurate results, it will be difficult for one to start there. But my point is, as per the question, using the values there, we don't have 0 to 0. So yeah, the graph must start somewhere from the points, the obvious dotted line, they can do it, but it must start somewhere. Thank you, leader.
All right. Thank you so much. Before I go to the question, I just want to project to you. I don't know if you are able to see. Colleagues, there are many types of trolleys that you can use. As you can see, I'm having the card, so it will depend on what the school has. Yeah? So can you see the card that I'm moving?
Yes,
Can
Prasem.
you see it? All right,
Yes,
yeah.
we can see
One
it.
school can use this type of a card. All right, it is easy to use. You can use it even if you don't have the runway. Okay, and then again, there is a lot of there is a lot of improvisation that you can also do. As you can see, do you see my hand? I'm using the clamp of the Rito stand. Because I did not have anything that I can use to connect my pulley. So you can also do some improvisation at the school level. Okay. And then I know that many schools have got this type of trolley here. Okay. So the main question that I want to ask is actually I just want to pose it to the house. Are we confined to using the 100 grams? Because you'll find that a school is having a different mass pieces, like the one that I can show you here. This one is not calibrated, but because I've got the mass meter, you can simply put it on the mass meter and check what will be the mass. Maybe you don't have a maybe you don't have a 100 gram at your school, but you have got 220. You have got another mass piece of 221. You have got one of 216. All right. So just some of the frustrations that the educators at the school level can be faced with. So I'm just throwing this to the house as to what do you think about that. If there is no response, I will just proceed in the interest of time.
We have Mr. Sibanyoni.
I had raised my hand earlier concerning the starting point of the graph. If we look at Fnet is equals to MA, it is in the form of Y is equals to MX. So it is expected that the graph will cut at the origin, which is 0:0. Thank you.
Yeah, thank you so much. All right, is there any other hand? He's actually talking about this one. I was just trying to make some notes as I was busy to say this is actually a straight line graph of the form y is equal to mx plus c, whereby a is what? A is your y, and your gradient is the inverse of what? Is the inverse of the mass, and then your f net will represent the x. And then because it is cutting at 0, the value of c will be 0. Thank you for that. All right, maybe we can proceed. Do you allow me, Diana?
Yes, Prasem. I don't see any other hands.
Thank you so much. Colleagues, do not say I'm fast. I can see that it is already late. Now, let's go to the questions. Colleagues, we don't have the memo, but I think the memo can come from the house. Identify one control variable in this experiment. Which one can we accept? You'll take the hands, maybe.
I have Mr. Mueller.
Wouldn't we say the mass of the trolley is controlled and the slope of the trolley track?
Okay. Do we all agree? Is there any counter? And is it the only answer that we can accept? If that is the case, let's
There's a
proceed.
hand. There's a hand,
Right.
Prasem. We have Anina.
Okay.
Good afternoon, colleagues. What about the length of the track, ma'am?
I think we can accept that. You agree with me, Diana? The distance will remain the same. The distance will remain
Yes,
the same in
Prasem.
all the experiments. Thank you.
Yes.
Can I proceed? Explain why the runway. Huh?
I think
Explain why
someone
the
has
runway.
unmuted.
Dr. Gibbons has always treated me and my family
Colleagues,
with
please
respect
just
and
keep on
humanity.
checking your
And I
mic
have a
that is muted. I'll check
I
the
had to buy
person.
a ticket just to talk to you tonight. And you're my cousin. That's because my time is valuable because I'm valuable. But so is Dr. Gibbons. And because
All right, thank you. Explain why the runway, the wheels of the trolley, and the frictionless pulley must be cleaned. That is too much. Anyone to assist us?
So wouldn't it be
Mr.
to ensure that we don't have friction, because that would be an external force that we're introducing into the system, which would affect your net force. So then,
Yes,
it wouldn't just be the mass pieces affecting the net force that we actually have. That's why we need to check not just the runway, but the wheels and the frictionless pulley, all the possible points of friction in the system, that we try and eliminate that as much as possible.
Thank you so much. Can I proceed, ma'am?
Yes, Prasem.
Okay, thank you. Draw a free body diagram or a level-free body diagram showing all the forces acting on the hanging mass pieces. Okay, just to put it easy, colleagues, how many forces are we going to have on the hanging mass piece? How many forces are we going to have?
2 forces.
3 forces.
2 forces. 2 forces.
Yeah, only the 2
Just the
forces.
weight.
Can you please name? Yeah.
It's just going to be the weight straight downwards and the tension upwards.
Yeah, that is the weight and the tension. Thank you. You allow me to proceed, madam?
We have Mr. Polo, whose hand was up.
Okay.
And I also have Mr. Shongwe as well. Let's give Mr. Polo and we'll go to Mr. Shongwe.
Afternoon, colleagues. Normally, when learners attempt to this question that talks about the free body diagram, we normally advise them to look at the mark allocation. So the mark allocation that I can see is 2. So meaning that most probably there will be 2 forces. So that would be your tension and your gravitational force. Thank you.
Thank you so much. Thank you so much, Nadia. Use the average velocity table what?
I think Mr. Shongo also wanted to comment after Mr. Polo.
Okay.
Yeah, thank you. Thank you, Program Director. Mine is now when it comes to the questionnaire colleagues and the colleagues where they will be marking the learner script. We need to be very, very careful, because we don't know what the marking guideline that DBE has. So, one, pertaining to the free body diagram, there will be criteria in terms of marking the free body diagram. So, therefore, thoroughly emphasizes from the side of the educator to the learners in terms of labeling. At first, the symbols, like for example, if learners tend to write W, it must be small letter W, because once it becomes typical letter W, they'll be penalized. Secondly, small letter T, if they were to opt to write T, they will be penalized. They must write typical letter T. Another criteria that I think will be there in terms of now the omission of the dot, and also the line not starting from the dot, there's a gap there using dotted line. So teachers, please, my humble plea, kindly emphasize that, because we might be just talking about it now, but when it comes to marking guideline in your different venues, you'll be marking as per the marking guideline using the criterion, whereas you didn't emphasize that. That is my humble plea, because many of the time our learners are losing marks when it comes to the response to the questionnaire. I thank you, Chair.
Thank you so much. Okay, the next question, they say use the average values in table 1, 2, and 3 to calculate acceleration of the system with one mass piece, the 2 mass pieces, and the 3 mass pieces. I think this was covered in the presentation of the subject advisors charts, no? Right, and then from there, the graph was also drawn. So colleagues, here we need to be very careful because as you can see, this graph carries about 6 marks. So on number 5, can I allow you to come up with the criteria on how we are going to allocate these 6 marks? You'll take the hands, ma'am.
Yes, I don't see anyone else yet. Okay, I see Mr. Banyoni.
Okay.
With the title.
Banyoni, the stage is yours.
I think it should be the title. Then the correct scaling of the axis. And number 3, it's the labeling of the axis. Then maybe we take any 3 points that are in line.
So I think you said, okay. He said the title. Title is 1 mark. 1 mark for the title.
One mark.
Okay, 1 mark for the title, and then you talked about the axis. Axis, you are saying the vertical and the horizontal axis. Do you include the SI units?
The correct scaling.
Scaling. Okay, thank you. Scaling.
And
thank you.
The labeling of the axis.
So is this 1 mark?
With the units.
Come again. Is this 1 mark? The correct scaling?
Yes, that's 1 mark.
All right.
Then any 3 points that are in line.
Any 3 points that are in line. Okay, you talked about the labeling of the axis. Labeling of axis with the correct SI units. Am I right?
Yes, that's correct.
So you give it 1 mark or 2 marks?
The labeling is 1 mark for each axis.
Okay, in other words, it will be 2 marks, ne?
But yeah, 2 marks.
All right, and then lastly, we've got the points in the line.
And it's remaining 2, I think, for the lines.
Just any points, or do we consider the line of the best fit passing through the origin?
I think best line fit is most proper.
Okay. Okay, ma'am, can I throw it back to you?
Thank you.
We have another hand, Mr. Sam, Mr. Mtali.
Good afternoon, colleagues.
Oh, sorry, ma'am.
Good afternoon, colleagues.
Good afternoon, ma'am.
Yes, I think it's 1 mark for the heading. Another mark goes to the labeling of x-axis. Another one for labeling of y-axis. And 2 marks for any 2 points, any 2 correct points. The last mark is for, it's supposed to be the straight line graph.
Thank you very much. Madam Charlie, when you were talking about point number 2, you say labeling of X Number 3, labeling of Y. So are you not
Yes.
emphasizing the SI units as well?
I do.
Okay, so they must be included. So it is almost the same
Yes.
as that of the first speaker. Eh? You did not deviate so
Yes.
much from. Yeah.
Or
Can
2
we
marks
accept?
for any 2 correct point, and the last mark for it's supposed to be a straight line.
Any 2, but it will be 6 marks, ne? Yeah.
Yes.
Yeah, that's
Yes.
correct. I think the House will agree with you.
Okay, thank you.
Thank you so much. Can we pass it?
Okay.
Yes, Prasem, I think we can pass.
All right. We are going to the last one part. Write down the mathematical relationship between acceleration and the net force acting on the constant mass. Any input?
Mr. Mueller?
You would be able to say F net, then the proportionality sign, so the alpha 1 over M.
Okay, that is correct.
Sorry, no?
That is correct.
Right in the between the acceleration and the net force. Sorry, net force, so it's F net proportionally sign A, not the 1 over M, because the 1 over M is that it's inversely proportional to the mass. Sorry,
Yes.
I misread that on the screen now for a second. Sorry about that.
Okay, F net is directly proportional to A, or to acceleration. Do you agree with him, colleagues?
Yes,
Agree.
we have Mr. Muelwa and Mr. Shongwe.
Okay.
Mr. Muelwa? Please unmute.
Okay. No, thank you so much. I wanted to make just some comments and some clarifications. When I was going through the charts, I could see that there were still some people were having doubts on the explanation that was given in terms of the mass which was supposed to be recorded and so on and so forth. Yeah. Let me make this clear. To determine the net force which is acting on that system, you need to be very specific. And in this case, you need to look at the mass which is doing the pulling. In this case, that is the mass we are looking. For example, the experiment that was demonstrated there. The net force is provided by this weight which is hanging the mass to go downwards. Okay, so in the calculation, since the weight is the product of the mass and the acceleration due to gravity, we know that. So we assume that there is no friction. We have talked about this, that we make sure that the wheels, and we use an inextensible string. All these things, we are making an assumption that friction must not be considered here. So we are going to say, in this case, F net will be equal to the mass, that is the hanging mass, times the gravity, which will be 9.8. So it is very important here, and to explain to the learners, because you need to find the difference between the net force versus the system mass, the mass of the system. A common point of confusion in this experiment specifically is the difference between the mass used to calculate the force and the mass used to calculate the acceleration. So let me explain that. To find the net force, you only need to record the mass that is hanging. This is the unbalanced force that is going to cause the motion of that system. Now, to find the acceleration, in this case, you must consider the total system mass, because the string is connecting the two of them, and these are considered as a system. So let me just give an experimental tip here. if you are trying to keep the mass, the total mass constant while changing the force, okay, to keep the experiment controlled, you need to start with a set of slotted, like it was demonstrated on top of the trolley. For each new try, one weight at a time, and you are going to record the new hanging mass for your force calculation. So by moving the weights from that trolley, rather than adding new ones, in this case, the system mass will be mass of the trolley plus the hanging mass. So this needs to be explained, colleagues, and it shouldn't bring any confusions to the learners. I hope I'm trying to be clear on that one. Thank you, colleagues.
Enner, thank you so much. Thank you so much. You have clarified it. Colleagues, we are almost at the end. I just want to throw this program back to Jabu. That is the owner of this particular program. Thank you so much, colleagues.
Brasem,
Okay.
I have Vanessa and I have Mr. Shongwe. Maybe let's give it to them before we can close it.
All right, sure. And then from there, let's give it to Jabune.
Yes, let's start with Vanessa. Vanessa, please unmute.
Good afternoon.
Good afternoon, ma'am.
I'm so sorry. I don't think the question in the chat was ever answered about the mass of the trolley, because in each of the tables, all three tables, they ask for the mass of the trolley, implying that that's the mass that stays constant. But it's in fact the mass of the system that remains constant, which is the trolley plus the mass hanger, as well as then obviously, so that is that's the whole mass of the system. So why are we only recording the mass of the trolley when in fact, if you add and take away 100 grams the whole time, that mass is going to differ? And I think that's where the confusion is coming in, because we are looking at the constant mass which is in the system, but why are we only recording the mass of the trolley?
All right, I think there's a response to that one. I'm not sure if Mr. Shongo wants to go for it and respond to that, or Mr. Mola wants to respond to that one.
So as for Mr. Shong, I won't respond to it because I will be fragmenting the information provided by Mr. Richard. I think he articulated very well, so I won't. But I have some addition after the discussion.
I think the question was answered, by Mr. Shongwe. I mean, Mr. Mel, the last one, when he articulated very well with the masses of the system. If you can check at the top there, it has the mass on the table, the mass of the trolley dots. It's where you put the mass of the trolley. But when you go down, you don't record it. It just you have where your mass is, the mass of the trolley. You write it down there. But when you take, you are going to record the mass of the system, if I understand it well. But you know exactly what is the mass of the trolley, because you're going to add all the masses that are there. They make the mass of the system. Then you take the mass of the system. Am I correct, Mr. Mwema?
Very correct, Mr. Stolle. Is it Vanessa, or I didn't get the name correctly? I think
yes,
that recording there where it says mass of the trolley, of course the masses are going to be different. It's just for reference that you know the mass of the trolley that you use, the learners use, is so much. Then to calculate the mass of the system, you are going to add all those masses that you have put let's say it's 100 grams, even if you change the position, you are going to record, like Mr. Shongwe explained in the first instance, that in those tables, for example, you are recording for 10 grams or a 0.1 for the 3 trials. You go to the next one with the 0.2, 3 trials, and so on and so forth. And when it comes to, I saw one of the questions there where you have to now calculate the acceleration there. Now you are going to find the average, because remember that the system now is moving everything. The whole system is moving. So the acceleration will be for the whole system. So that will be clear. On this graph, I thought maybe the marks were just too much for me. The maximum I would give there would be rather maybe 5 marks, because usually they give 1 mark for labeling the axis, drawing the axis and labeling. That usually it's 1 mark, and the heading 1 mark, 2 marks for plotting the points, and of course 1 mark for the type of a graph, whether it's a straight line graph and so on. So the maximum I would give is 5 marks there. But anyway, we'll see what they come up with in that. Otherwise, I'm impressed with the presentation, colleagues, and even the engagement from the teachers. I'm so impressed. At least without the questions, we will never get to know what issues are there. Otherwise, I'm so happy. Thank you.
Thank you so much.
Prasem, I don't see any
Can I
other
talk?
hand.
Okay.
Okay, there's just one. Maybe before we give it back to Brajabu, we have Jacobs, Mr. Jacobs or Miss Jacobs.
Hello, ma'am. Thank you. I would just like to know, you mentioned about a register. How do we sign the register? Is there a register?
Yes, it is there. Esther, are you still there? I thought I saw it on the chat box.
Yes, it's in the chat box. Maybe let me just copy it again so that
I
you
would
can have
appreciate
it.
that. Thank you.
I think we can give over to Brajabu Prasem.
Sorry, program director. Sorry to interject. Sorry. Can I say something before the chairperson pertaining to question 6
I'll give you.
and also responding to a question pertaining to rounding off? There's a question on the chat there pertaining to rounding off. Can I end that slowly?
Yes, hit, sir.
All right. Okay, colleagues.
I was
Now,
waiting for the chairperson to
yeah,
give
mine
you.
is for my colleagues there who are in the classroom. Colleagues, let's not overlook the expression in number 6. That says mathematically. Can you please pay attention to this, because I've been Mr.